Okay, and here are the last two example problems. So we have the double replacement reaction between lithium sulfate and silver nitrate to produce lithium nitrate and silver sulfate. If 25.3 milliliters of silver nitrate, we've got a volume and a concentration, is mixed with 12.2 milliliters of 1.66 molar lithium sulfate, answer the following questions. So to start, we want to know what's the net ionic equation for this reaction. So remember, group 1 and nitrates are spectators. So lithium's a spectator, nitrate's a spectator. If they start spectators, they end spectators. So the net ionic equation for this reaction would be, now silver is a transition metal, but we can work out its charge from the nitrate of being +1. It's also one that you should memorize. And the sulfate, I know I flipped the order there. It's not super important. A plus B is the same as B plus A. So we're going to make our silver sulfate a 2-to-1 ratio. So we want to know how many grams of silver sulfate will form based on all this information. So similar to one of the other problems, we're going to have to go from volume to moles. So, oops, wrote that upside down. No, I didn't. 1 liter over 10 to the third milliliters times 0.83 moles of silver nitrate for every 1 liter. And then our ratio is 1 silver sulfate for every 2 silver nitrates. And then we will do the same for our lithium sulfate. And the ratio is 1 silver sulfate for every 1 lithium sulfate. So mils are gone, liters are gone. Oh, sorry, we still have moles. All right, so let's calculate it. 2. So this would be 0.0105 moles of our product. 2 over 1,000 6, and it's a 1-to-1 ratio. So 0.0203 moles of silver sulfate. So the silver nitrate is our limiting reactant. That's what we're going to work with. All right, so let's convert that into our theoretical yield. So to go moles to grams, we're going to multiply by our molar mass of 490 grams for every 1 mole. So we'll do that. that, and we get 5.14 grams silver sulfate as our theoretical yield. All right, now we've got a percent yield part here. So it says a chemist only recovers 53% of their product. We want to know what their actual yield was. Well, we've already seen a problem like that in this set, so we can just plug that in. Sorry, substitute that in for what we're looking for. Now I'm going to do all of my work at once in the calculator. So we're going to have 53 over 100, and then multiply that by our previous answer. So we get 2.73 grams silver sulfate solid actually recovered. All right, now problem 6 is kind of the grand finale problem here. It's going to combine a lot of stuff together. So we have the synthesis of iron and chlorine gas to make iron 3 chloride. So we have 1.13 kilograms of iron solid, and it's exposed to 12.1 liters of chlorine gas, so that's a lot of gas, at 30 degrees Celsius and a pressure of 0.982 atmospheres. So we want to know how many grams of the iron 3 chloride should be formed. The starting amounts of our reactants, limiting reactant problem, but one's in grams, one's in liters, temperature, and pressure, so we're going to have to find moles there. So let's start with the iron. Now, we're going to have to convert down from kilograms. As you may recall, there are 1,000 or 10 to the third grams for every 1 kilogram. And then, so this is iron, we can convert this into moles by dividing by the molar mass of iron, which is 55.85 grams. And then we'll convert this to moles of the iron 3 chloride. For every 2 of those, there's 2 irons. Okay, so that would be 20.2 moles of the iron chloride. Now, we do need to get to moles of iron chloride from moles of chlorine, so we're going to have to do the ideal gas law to start. All right, so I've gone ahead and rearranged the ideal gas law here, and this will get us to moles of chlorine gas. Substitute that in, and we'll get 0.478 moles of chlorine gas. Now, to see how many moles in theory this will produce of our product, we use our mole ratio. 2 iron chlorides for every 3 chlorines. Chlorines are gone. And we get 0.319 in theory. Okay, there's no real contest between these. 20.2 moles versus 0.39319. This is our limiting reactant amount. Okay, so to get our theoretical yield, we'll take our moles of iron 3 chloride produced by our limiting reagent, multiply by its molar mass, and then we'll be good to go. So in theory, we will make 51.7 grams of the iron 3 chloride.